Hello, everyone. Welcome to Think and Practice once again. Thanks for coming. Thanks for joining. Today, in this video, I'm going to cover very interesting topic on decorator pattern, and this is one of the favorite patterns of mine. There is a reason also. I'll try to tell you if I can explain in words. So I'll quickly introduce this, what I'm going to cover in this video. So we'll start with problem introduction, revise the decorator pattern structure with participants and collaborations, etc. Then we'll think about decorator. How can it help us here to implement this kind of scenario and the use case or the example, right? So, and also we'll go through the code implementation, which I already prepared, and we'll go through that and understand how it can be implemented and what are the benefits from this implementation we'll get to have. That also will I'll gonna cover here. Okay, so let's start quickly. So this topic is related to, let's say we have a data, okay? We have a data, we want to perform some operations, let's say encryption or compression, okay? Or the vice versa, we can say decryption or decompression, whatever, right? So we think about encryption and compression together. So let's say we have a behavior and we want to implement both of them together. So a direct way, obviously there you encrypt that and compress that. So this is was just a functional way, but object-oriented way. Uh, how can we achieve this one? So let's start with some revision on the decorator pattern. So I have a picture here. So here in this diagram that looks a little messy, but yeah, it's very easy to understand. Two participants, one is component, another is decorator. Okay, that's two. And there are others such as concrete component and concrete decorator. Those are nothing but implementation of them. Okay, so relationship between these two, component and decorator, is very simple. Decorator is actually decorating the component. Okay, so it associates a component within that, as well as it it extends the behavior of the component. So two things are happening here: extension as well as it unwraps the another component here. It could be decorator, it could be component. That's basic thing, right? So and the operation wise it simply performs here. We know component dot operation, so it delegates to next decorator or the concrete component this operation, right? So here in the concrete implementation also we have separate operation implementations. These are very simple. We'll delegate it to our parent as well as it performs some other operation. That's very simple. Okay, by example to understand that would be very simple. Okay, later on we'll talk with this code explanation. So I'm coming back to my overview. What we next is, so let's think about this. Okay, let's say we have a data. We want to perform first encryption. Let's say first compression and then encryption, and then we'll to send it or we want to save it, whatever, right? So decorator is nothing but modification to a behavior. Let's say save behavior. So we are trying to modify it with the encryption as well as compression, right? So the actually it implements without extending how to modify the behavior. That is what this example of a structural design pattern named decorate, right? So I'll go through implementation that will be very clear for us to understand. So data component, yeah. So I'll go through this two are abstract one. I have highlighted this two, data component and decorator, right? So component here, this is our component, and data decorator, which is our decorator of this component. Okay, so this is very simple. Component is having one method save. It receives the data as a parameter. Let's say some string data we are gonna receive here. And decorator, as I said, it wraps a data component within that as well as it extends so that it is a behavior. It is having a same behavior save method of the component it inherits, right? So what happens? Let's say we have a concrete implementation of component called data saver here. It's just perform save operation here. Okay, so what it does, it saves to a file. Let's say it's very simple, right? It could be something else. We'll say send it to network or something else. Okay, could be possible. So let's say this is our component, and there are two decorator I have created. Okay, this compression decorator as well as encryptor decorator. Okay, those are very simple, extending the data decorator. Okay, so our abstract class data decorator is there, and it's just extending that. So we know the data decorator is having a component within that, right? So just what is the use of the compression decorator? It should be compressing the data, and then it's delegating to next step. That is what we want to have. So here, these are the operations for the compression, and then we'll delegate to save method with the same compressed data, right? Similarly for encryption as well, like we are encrypting first and then we'll delegating it to. So we can change the order as per the scenario, right? So here, first we want to encrypt the data and then we'll want to save the data further, right? So let's say I have created a client. So just to understand that how it wraps it. So our main concrete component here is a data saver. Okay, so data saver is there, and data encryptor is there, and compressor we have prepared. So what happens? It unwraps the data saver first, and then it unwraps the encryptor second. Okay, and we'll call save method on compression. So first compression will be performed, and then we'll perform encryption, and then we'll perform actual save operation. So this way it delegates the request. Right. So pretty simple, correct? Okay, yeah, so this is what our implementation for this use case. Okay, there could be other use case you can think of, right? It's very simple. So it's decorating, and that's why by name as well as by the work, this is my favorite. Okay, let's see, think about what are the benefits. So one benefit we know, that is, there could be something else too here, right? One is compression, another is encryptor. There could be something else. Let's say we want to log as well. What are the requests are coming for our compression and encryption, right? So we can log that. So log decorator, something similar, right? So this kind of behavior also can be added. So it's very scalable in nature that we can add more decorators here, as well as very pretty flexible. Because let's say we reorder the operation here. Yeah, first we can perform compression, then encryption, or encryption, then compression, or something else, right? So it's very flexible to build this kind of composition uh, and this kind of structure, right? And that's why it's a structural design pattern, correct? Right. So it's very easy to, as well as it's very reusable. It's a reusable structure because uh, directly instead of saving over the compression, we can save directly on the data saver too, or it could be encryptor component we can save, right? So reusable, it can be used differently as well as testability is definitely there because each different components we can test it separately for that behavior, right? So these are the good benefits, and also it's an open close we can say, right? It's new class can be added, so no modification to existing is required in that case, and single responsibilities are given here, and some injections also we can do. So directly there are dependency, right? So we can inject the dependency. So data dependency inversion also we can apply here. So this way it's very good, easy to implement, easy to understand. This is right. So yeah, these are the benefits. Okay, so I'll wrap it up, and I'll continue on that and cover some other use case in the different uh, video. Okay, thanks for watching. If you like this video, please do subscribe. Bye.